Hello, Dave Kenworthy here. It's 31st of the 5th, 2022, and I've got a new book. And it's this. Ancient Measurement by Roland Boucher. And I'm looking at his summary of his findings. And he says Table 1.1 summarizes the ancient standards of length and the resulting volumes and weights this report will establish. And we look at the lunar standard of Lagash. I hope you can see that. The lunar standard of Lagash is 1011.24 the step, and the foot is 337.1, which is a third of it. Now, there's a problem here for me. Not that there's anything wrong with Roland's findings, quite the contrary. I really don't want this lunar standard of Lagash to be 1011.24 millimeters. I want it, because that's 39.8126 imperial inches, and I want it to be 1005.84 millimeters, which is 39.6 imperial inches. But that's not what Roland's discovered. Now, I've been studying the work of Professor Alexander Thom, and I've also been studying the work by Algernon Berryman, Historical Metrology. Now, the interesting thing for me is that Professor Thom was a professor of engineering science at Oxford University. Algernon Berryman was the chief engineer of the Daimler Corporation that built luxury cars. And Roland Boucher is an engineer, a highly qualified engineer who has turned to ancient measure in his later years, exactly as I have done. I started my studies 10 years ago, and I think that coincides with when Roland started to do the same. And this is what he says, which is intensely interesting. I will never forget the length of their new yard meter. It was 993.7 millimeters. 15 years later, when studying ancient Sumerian standards of measure, I found a yard that was exactly 993.7 millimeters long. The obvious question was, did the Sumerians develop these standards using a pendulum? I had to find out. This report describes some of what was discovered. Now, what I'm going to try to show now is that the pendulum lengths that Roland's discovered can also be interpreted as lunar measure, especially when we use the divide the I think what he calls the step, when we divide that by 3 to get the foot. That's when we find lunar measure, but we only find it in millimeters. And I think that Jim Wakefield has also found this, that the metric system, if we convert the imperial to metric, we find these lunar measures. And I'm going to show you now how this measure of 1011.24 millimeters can be compared with the unit of measure that was on the statue of Gudea, which is 1005.84 millimeters, and that produces a foot of 335.28 millimeters. And in the book, this is what Roland says. It appears that Gudea's foot travelled to Europe, where it became the Anglo-Saxon foot of 335.28 millimeters. This four-figure match in dimension is unlikely to have been the result of chance. So what I want to prove here is that it definitely isn't the result of chance. And this is Roland's lunar standard of Lagash, and this is Gudier's statue discovered by Berryman, 39.6 imperial inches. These are the two units I'm comparing. And the way that I do it is I take the smaller one from the larger one to determine the difference between the two. And it's 5.4 millimeters and it's 0.2126 imperial inches. So I take that from the larger one. Now if we divide that by that, we show that we're using 25.4 millimeters to the inch. So that divided by that is 25.4. Now it's interesting because now we divide these into this and this, and we get these numbers here. 187.26666 recurring. And here we get 186.266 recurring, because this is unity. This is creating unity. One unit difference. So we get 186.267 there and there. And we get the same when we use the inch. It can't be any different. But what we find is we've now got a unit attached to 187 of 0.26666 recurring units. Now this is something that I discovered at Stonehenge. It's a unit that comes to the surface, this 2666 recurring, when you start to do this kind of work. And what we can do is apply it to this, and this. When we divide that by 0.266, we get this unit, and we get this unit here. And when we look at these two, we can see immediately that the unit that's separating them is 700. So what we can do is convert this 700 into millimeters. And when we do, we find that it is 1008 millimeters, this unit here, which is a bridge between this one and this one. So we've got these three units now, and we can divide them by 3 to get the foot. So the foot, when we divide that by 3, is 33708. We divide this by 3, we get 335.28. And this is the dead giveaway, because I'm very familiar with this number, 336. Because it's 28 times 12. When we're talking about lunar measure here, you couldn't become any more lunar than a 28-day lunar month. Everybody knows about that. Now then, what we've got is the millimeter is representing a day. When we use the foot in using these pendulum lengths, or using this pendulum length. Now, I'm not sure that this is the way that Roland's interpreted this, because I've not really got past the first few pages of his book, because I keep going back and messing around with these calculations. And today I've found this, and I want to point it out to Roland. Now, what we do is we know that's 12, so we divide by 12 and multiply by 13, because this 364 is the number of days that I work with at Stonehenge. And it's definitely what the ancients were using, because it's 7 times 13 times 4. And they were using whole numbers in their calculations. Now, the fact is we're getting these measures here because of the length in millimeters, but it's very possible that they were using a different measure that will produce whole number measure here, because we've got a whole number there. I'm sure that if we divide by 0.12 of a millimeter, which I haven't done, we'll get whole numbers here. So so we're looking at lunar measure in millimeters, producing a lunar month there and there and there, and a solar month there. Now The 13.2 inch measure is producing 363.22 days. I've no idea why that would be produced, but I can say with certainty that when we turn the lunar measure into inches, we're getting this 13.2, and that is it's the Babylonian foot, or the Indus Valley foot, or the Sumerian foot, whichever one you want. And it's also the foot that was in use when the Normans came to the UK, and it was consolidated into a 12-inch measure. Now, 1320 is 10 times 11 times 12. So we can see that when we use inches now, we're into an area of mathematics and also solar and lunar measure. And 13.2 multiplied by 27.777 is 366.667 days. And this is the number of days that I'm suggesting is represented by the Giza base as discovered by Colonel Vyse. Now, if we multiply 13.2, if we divide it by 12 and then multiply it by 13, we get 14.3. Now, I'm not going any further with that, but what I'm saying is that this 13.2, when multiplied by, that's 1000 over 36. When multiplied by 1000 and divided by 36, gives us 366.666. And in this instance, that's days. So what we're finding from the two measures is we get this central column where the length of the unit is 1008 millimeters, and we can divide that by 3 to get the length of the lunar year when we use a 28-day month, and we get 364 when we divide by 12 and multiply by 13. And these units, 12, 13, 11, 10, 7, because we're getting 700 in this instance, and also 17, they're the ones that we find in Tom's work and in Berryman's work, and they're overlapping all the time, and now they're coming out in Roland's work. And Roland's work is so important because we've now got a line down through from the Sumerians through to the design of the Giza pyramid using the pendulum. There's a great suspicion that pendulums were used by the Picts and before them the people that populated the Pictish area of Scotland, the carved stone balls that have been discovered. And this work is taking us through Berryman, and it takes us to Tom, and it takes us to the calculations that are needed to discover the astronomical aspect of the design of the Giza Great Pyramid. So that's it for now, and really this is aimed at Roland. So thanks for that.